Even in ancient times, people were looking for the connection between numbers and beauty. One of the most ancient myths related to music, harmony, and the invisible laws of the universe is the myth of Orpheus, the Thracian musician, poet, and prophet whose origin is associated with today's Bulgarian lands. Orpheus believed that music contained beasts and moved stones. Mathematics is everywhere, even in the music of Orpheus. Pythagoras showed this experimentally using a monochord, a single string instrument, and found that the most harmonic intervals, octave, fifth, fourth, are obtained when the string lengths are in relation to mutually prime integers. For example, 2 and 3, 3 and 4. According to him, it is these numerical ratios that stand behind the beauty of music and lay the foundations of theory of musical harmony. In the ninth book of War and Peace, Tolstoy describes how the hero Pierre Besukhov falls under the influence of Masonic ideas and begins to search for a deeper meaning and predestination behind the events in his life. Prompted by one of the Freemasons, Pierre became acquainted with the passage from the Apocalypse, which says that the number of the beast is 666 and that it is the number of a man. In an effort to find a connection between historical events and prophecies, he used an alphabet in which each letter corresponds to a certain value and calculated the sum of the letters in the expression L'Empereur Napoleon. According to him, the resulting value is precisely 666, which leads him to believe that Napoleon is the beast of Revelation. However, this calculation does not coincide with reality. With accurate calculation using the specified alphabet, the sum of the letters in the phrase L'Empereur Napoleon is 661, not 666. The difference of 5 arises because the word L'Empereur begins with the contracted article L, which is actually an abbreviation of LU. If the full form L'Empereur Napoleon is used instead, another letter E with a value of 5 is added, bringing the required sum of 666. In addition to being a symbolic biblical number, 666 is also mathematically significant. It is the sum of the first 36 natural numbers. This is the 36th so-called triangular number, which is calculated using the formula 36 multiplied by 37 divided by 2. This numerical pattern is objective and real, unlike the letter-based calculation, which relies on arbitrary linguistic and graphical conventions. In this sense, the number 666 can only be achieved if the form of the word is consciously chosen so that it corresponds to a predetermined result. In the engraving Melancholy I, the German artist, mathematician, and thinker Albrecht Dürer depicts an allegorical scene dedicated to the creative crisis and intellectual search. The engraving is rich in symbolism. A female figure with wings, geometrical tools, an hourglass, and a celestial globe. All this reflects a man's desire to understand the universe through art and science. In the upper right corner of the engraving is a magic square that combines mathematical precision and symbolic depth. The square is 4x4 table in which the numbers from 1 to 16 are arranged so that the sum of each row horizontally, vertically, and diagonally is the same, 34. This number is called magic constant, and for a square of size 4, it is calculated using this formula. When n equals 4, we get m equals 34. This is what the square looks like in the engraving. An interesting detail is that the numbers in the lower center row, 15 and 14, from the year 1514 in which the work was created. This shows how Dürer uses mathematical structure not only as an abstract concept but also as a vehicle for personal and historical meaning. One of the simplest magic squares is the 3x3 square, in which the numbers from 1 to 9 are used. With him, the magic constant is 15. When presented with a square that has missing values, we can complete it. Such problems show how magic squares combine logical thinking, arithmetic, and symmetry, and in Dürer's case, aesthetics and philosophy. They remind us that mathematics is not just about calculation, but also a language for expressing ideas, emotion, and spiritual aspirations. The painting, Counting in Their Heads, was painted by the Soviet artist Nikolai Bogdanov-Belsky in 1895. In it we see students in a rural school gathered around a blackboard with a math problem written on it. The artist was a student of the famous Russian pedagogue Sergei Rachinsky, who taught mathematics and believed that children could solve complex problems mentally using logic and observation. The year in question, 1895, is not a leap year, so the number 365 can also be interpreted as the number of days in a year. The problem can be solved in different ways. A classical approach is to use the formula for the sum of the squares of the first n natural numbers. We apply it twice, once for the numbers from 1 to 14 and once for the numbers from 1 to 9. Then subtract and divide by 2. Another way is to find the sum of the squares of the first 3 numbers and then the sum of the squares of the last 2 numbers, and as we can see, they're both equal to 365, which again gives the result of 2. The number p is one of the most famous irrational numbers in mathematics, which represents the relationship between the circumference of a circle and its diameter. It begins with the digits 3.14, 15, 92, 65, 35, and continues indefinitely without repetition. Even before the advent of computers, people used rhymes and poems to remember more of its numbers. For example, the sentence, "May I have a large container of coffee?" helps us remember the first 8 digits of a p by the number of letters in the words. There are also longer poems that encode 10, even hundreds of digits, and one of the most famous is a version of Edgar Allan Poe's poem containing over 700 digits per p. In addition to words, the number p can also be turned into music. Each digit from 0 to 9 is matched to a specific note or rhythm, with the digit 0 becoming a note C, 1 becoming D, 2 becoming E, and so on, including different rhythmic values from an A to a whole note. This creates a unique, uninterrupted melody that reflects the mysterious nature of the number. The International Day of the Number P is celebrated on March 14 precisely because of its first digits of 3.14. I'm Elisabetta Casale, and together we follow the traces of mathematics in Asian art and literature. Thank you for watching, and goodbye.